while ago, played with iax then, and kind of, for one reason or another, drifted off and not used it since. And we're kind of interested in letting you know that things are happening still in the iax world, and some quite nice stuff is happening. So that's the kind of purpose of the talk. So, you know, what was there when you first looked, or last looked, I suppose? You know, it's a simple, lightweight VoIP protocol. It goes through firewalls and NAT really nicely. It's a very simple way to start up, getting a couple of asterisks to talk to each other, that kind of stuff. It is very simple to set up, and that's kind of a very strong point from our perspective. It works in most circumstances pretty quickly. There's a perception around, and I'm going to challenge this, that it's really only suitable for a small install, you know, a couple of links perhaps, a few channels, and also that it's asterisk only. Again, I'm going to challenge that, but you know, when you first looked maybe 2-3 years ago, that might have been true. So that's the sort of background perception I believe most of you may have had of iax. But things are changing. Ed here has been doing sterling work on getting it standardized, because one of the criticisms was, you know, hey, it isn't a standard, so why should we use it? And there's kind of a lot of pullback from that. So there is now an iax2 draft RFC, and the great thing is it's about 100 pages. Is it 108 or something now?
I think that's what it's.
But it's readable. If you sit on a train journey, you can read it from beginning to end and have an idea about how the protocol works. It's in good shape, it's a readable document, and you can implement iax from it. You can sit there and work your way through it and write your iax implementation based on that. And that's a huge contrast to the SIP-stun RTP mess, where there's something of the order of 100 RFCs you need to read. And they're not thin either. So realistically, nobody actually reads all of them. They implement some kind of subset that may work or not with other subsets. So here's the URL of the current draft, which I think expires in October.
In October, it should be. There's another issue coming out in about, it's supposed to be done this week. Phase 2, it's been approved for publication. So it's gotten past all the technical hurdles. Now I have to go and do some word processing and correct that sort of stuff.
But I think that's a huge step forward, and I'm really pleased that that's happening, because it allows a lot of people to go away and feel much more secure about using iax. So, and one of the other challenges with iax in the early days, so in asterisk, 109 or something, is to do with the way that iax is constructed. It uses single UDP port, and that's one of its strengths, of course, in that that's why it goes through firewalls and that's why it NATs neatly. But there are some problems with that, because the consequence is the easy way to deal with that is all of your audio data comes into one place, so the easy way to deal with it is to deal with it on a single thread. And that doesn't scale very well onto multi-core CPUs, which we're all using now. So that was seen as a kind of a big hurdle. And likewise, there's what's probably now seen as a design decision in iax, where the audio packets are labeled in terms of the sending end, not the receiving end. So the receiving end gets this packet and has to work out which channel to associate it with by looking in a lookup table against the sender's numbers. And that can take a while to look up, and that's been seen as an inefficiency, and it was quite inefficient in like 109 or